Hi, my name is Frank Lavinia, and today I'm here to talk to you about why model context protocol feels like the missing link in AI integration. Picture this. You're working on an internal AI assistant to help triage support tickets. It needs to fetch customer history from a CRM, suggest knowledge base articles, and escalate issues via Slack. Each task requires a custom integration, an API shim, or a brittle little script that breaks the moment a vendor changes an endpoint. Sound familiar? For years, developers have lived in this fragmented reality, cobbling together brittle connections between systems, each integration a bespoke artifact. But that may be about to change. The Model Context Protocol is an emerging open standard developed by Anthropic and now adopted by many major industry players. And it promises to simplify how AI models interact with external tools and data. And it's a deceptively simple idea, but like many transformative shifts in computing, think HTTP or REST, its power lies in its ability to create a universal surface for connection. And in that way, MCP is more than just another protocol. It's a platform primitive for the AI native era. AI systems today are incredibly capable. They can craft emails, debug code, translate languages, but they often work in a vacuum or silos. Getting them to operate meaningful with real world systems requires a patchwork of glue code, custom prompts, and a little bit of human babysitting. It's not just inefficient, it's a real barrier to innovation. Let's say your AI assistant needs to pull current sales figures from your BI dashboard, search support documents for a known issue, or call a service to initiate a return for a customer. Even if each system has a well-documented API, your model doesn't really understand how to use them. Developers must build complex retrieval pipelines or create brittle function calling wrappers. And that's assuming the model even has access to those tools in the first place. But what if we flip the script? What if the systems told the models what tools were available, what they do, how they work, and what kind of data they accept? At its core, the Model Context Protocol provides a structured way for systems to expose their capabilities to language models. This includes tools, functions that a model can call. For example, look up customer by email. Resources, structured data that the model can reference, like a product catalog or user records. And prompt templates, pre-written prompts the system can use to guide model behavior. For example, summarizes customer sentiment history. Think of MCP as a contract, a way for external systems to say, here's what I can do, here's how you can talk to me. All of this is described in a machine-readable way so that models, whether from Anthropic, OpenAI, or elsewhere, can understand it. In traditional software architecture, Apache Kafka acts as a central nervous system. It decouples the producers and consumers, allowing systems to communicate via a standardized event stream. You don't really know how the producer made the event or what the consumer does with the data. As long as you both speak the Kafka language, things just work. Well, MCP plays a similar role, but for AI interaction. Instead of logs, it exposes context, tools, resources, and prompts in a standardized schema that models can interpret and invoke. It becomes a substrate, a kind of universal interface for cognitive operations, letting tools be composed like building blocks. And just like Kafka helped usher in the modern day data stack, MCP could help build the modern AI stack, one where every tool, every system, and every data set is natively usable by an AI model with minimal glue. Let's bring this to life. Suppose you're building an AI assistant for a cybersecurity team. With MCP, you could expose a handful of tools, such as Query Threat DB with a parameter of the IP address, to look up known malicious actors. Summarize log file, which would provide a high-level overview of suspicious activity. Trigger an incident would initiate a playbook to respond to the threat. It could kick off all sorts of work streams, up to and including sending out text messages, emails, and Slack messages to the on-call team. You also publish resources like a team's on-call calendar and recent vulnerability reports, and define a few prompt templates for escalation language or ticket filing. Now, when the analyst asks, has this IP shown up in any previous reports, the assistant doesn't guess, it calls the tool. When the analyst says, generate a summary of these logs, the assistant doesn't hallucinate, it uses a predefined prompt. This isn't just convenience, it's the difference between AI as a novelty and AI as a teammate. The most exciting thing about MCP isn't just its technical elegance, it's the momentum behind it. As of this recording, MCP has official or in-progress support from Anthropic, OpenAI, Microsoft, and tooling platforms like Replit, Cursor, Sourcegraph, and Zed. Surely by the time you're watching this, that list has only grown longer. And because the protocol is open and platform agnostic, it's becoming the lingua franca for anyone building LLM-powered systems. Whether you're a solo dev writing in Python scripts or an enterprise architect managing dozens of AI-enabled workflows. It's not hard to imagine where this could go. We may soon see tool marketplaces where MCP-enabled tools can be discovered and shared across organizations. Versioned tool contracts, ensuring backwards compatibility as APIs evolve. Security layers and permission schemas, so that models can only access what they're supposed to. And finally, tool chaining, where models compose MCP tools into workflows without human prompting. Eventually, this may all just be assumed, very much the same way that HTTP is just assumed. You won't think about MCP integration any more than you think about TCP/IP when you open up your web browser. You'll just expect your model can see and use the tools that you've made available. And that's the real promise of MCP. Not just making AI smarter, but actually making it useful when and where it matters most. We're at an inflection point. The early days of AI were focused on capability, how much a model can do. This next phase that we're about to enter is about connectivity, how well AI fits into our existing systems, workflows, and expectations. MCP is a subtle shift, but a profound one. It turns AI from a black box into a platform citizen. And for those of us building the next generation of software, it offers something we haven't had in a long time, a standard we can build on. But there's a crucial detail here that's easy to overlook. MCP is a specification, not an implementation. That means trust, reliability, and security aren't baked into the protocol itself. They depend entirely on how it's deployed. As the number of MCP servers grow, and hundreds already exist, and probably into the thousands by the time you're watching this, the ecosystem must grapple with the issues of trust, server provenance, and secure execution. Who's running your MCP server? Can you trust it? Could your model trust it? And this is exactly where open source shines. Transparent, community-audited MCP servers give developers a fighting chance to verify what their systems are actually doing, not just what they're told. Security by design becomes possible when implementation details are visible, testable, and collectively improved. In other words, MCP sets the rules, but the players in the game matter. And if we want this future to be as powerful as it is promising, we need not to just invest in the protocol, but in trusted, open implementations that uphold the spirit of the protocol. I'm Frank Lavinia, and you can go to the following URL to find out more about what Red Hat is doing in AI.